over covalent bonds. This is part of physical science. So when we talk about covalent bonds, they're between two molecules or two atoms, and electrons get shared. So the electrons get passed back and forth. So we have to remember our octet rule. Our octet rule is the rule of 8, which means that all atoms want a full outer shell. So those that are in period 2 down to period 7, which is row 2 down to the bottom, want 8. So oxygen's in period 2, so it wants a full shell of 8. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. So it needs 2 more. And the only way it can get 2 more is from hydrogen. So hydrogen will share one of its electrons. This hydrogen will share one of its electrons. And then oxygen will have its 8. 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen, on the other hand, is in that first row. And if you remember your Bohr models, that first ring, the maximum it can hold is 2. So it wants to be like helium. So oxygen will let hydrogen borrow one of its electrons, and hydrogen will have 2 every once in a while. So these electrons will go and they'll pass, and they just kind of do this maneuver around where they're sharing electrons as they go. Covalents are going to have a weaker force of attraction than ionic bonds. So if you remember ionic bonds, that's when the other atoms are going to take those electrons, they do not give them back, and they're going to have a charge. So sodium will have a plus charge because I have 1 valence electron, so it's going to have a positive charge. And then chlorine has 7 valence electrons, so it's going to bring in 1 more to get that 8. So I will have a negative charge. And if you need to see a video on ionic bonds, I'll put a link down below and you guys can go to that video also. Covalents are a little different because here with ionics, these charges stay the same. But in covalents, remember, they share. So hydrogen would have some every once in a while, oxygen would have some every once in a while. So since they're going back and forth, that charge is flipping and changing. So it's not as strong as an ionic bond. So these covalent bonds are not as strong as an ionic, so they're a little bit more able to move and break down. So covalent bonds are going to be between 2 nonmetals. So over here you can see I have all of these metals. All these red boxes are metals. And over here all these blue boxes are nonmetals. So right off the bat I can tell if I have a covalent bond if it's between 2 nonmetals. So I look at water, which is oxygen and hydrogen. They're both nonmetals. So that right off the bat tells me it's a covalent bond of some type. Covalent bonds are going to be more stable when they come together. So let's look at fluorine. Fluorine has 7 valence electrons. So that means it has room for 1 more electron. To be happy, it wants 8. So this fluorine will come in. It will take this electron, let this fluorine share it. So this electron will go around here, give this fluorine 8. And then one of fluorine's electrons will come over here and share with this second fluorine. And that will go around, and then this one will have 8. So I'm constantly moving back and forth. One will have 8, one won't, and then I kind of flop back and forth. This will also change my charges. So when this one has an extra electron, it's going to be more negative. And when this is more negative, this will be positive. But then it flips. This electron comes over here. This will become more negative and this will become positive. So it's a constant moving back and forth of charges. So here I have, this is how I would show it with a dots, are these models like this. Covalent bonds will be softer because again, those bonds aren't as strong as an ionic bond. So they're going to be a little bit softer. Some of them I can be able to push and shift, and you can see the molecules, how they move. They're able to break apart a little bit easier. I can have different bonds. I can have 1 electron pass back and forth. I can have what's called a double bond where 2 electrons pass back and forth. A triple bond is when I have 3 electrons passing back and forth. So each of these lines represent 1 electron moving back and forth. There's two different types of covalent bonds. I have what's called a polar covalent bond and a non-polar covalent bond. So polar would be water, non-polar would be something like methane or something to that extent. So before we talk about polarity and all that, let's talk about electronegativity. So this is the greediness of electrons, how greedy electrons are wanted by certain atoms. So over here on this side of the table, see these red boxes? These are atoms that are super greedy for electrons. They want all the electrons. They do not like to share. They want to keep all the electrons. And so every once in a while, when you have something, so here I have oxygen and hydrogen, and you can see my numbers way off. I have 3.5 here for oxygen, 2.2 or 2.1 for hydrogen. This one is saying that this has more an affinity or more of a desire to have electrons. So oxygen is going to pull and hold the electrons a lot longer than hydrogen will. So when we talk about polar covalent bond, these are when the bonds are shared unequally. And the best way to kind of look at that is to look at the electronegativity chart that you have, or that one on that previous slide. So this is kind of what you need to do. So I have hydrogen and I have chlorine. And one atom is going to attract more electrons than the other, but I'm not sure exactly which one it is yet. So I look at my electronegativity chart. Chlorine is 3.16, hydrogen is 2.2. So this is a higher electronegativity, so this has a very high greediness for electrons. So chlorine is going to want hydrogen's 1 electron. Chlorine has 7 valence electrons, so it wants hydrogen's 1 valence electron to give it 8. And chlorine is going to keep that electron for a long period of time. And then this will have a negative charge. Then every once in a while, chlorine will come over here and let hydrogen have an electron just for a second, and then it's going to pull it back and keep it over here. So this will have a positive charge most of the time, and this will have an affinity for a negative charge most of the time. Okay. We show that with this symbol here. This means that this is going to be my electronegative element that's going to hold the electrons longer. And this means that this one will not have electrons for a long period of time. And I'm also showing here with this one line that I have 1 electron being passed back and forth. Because remember, chlorine has 7 valence electrons. So 1 electron will come from hydrogen to go around chlorine to fill that octet rule. One side of the molecule is negative. So this part here is negative. And the other end is positive, because this is negative because I have electrons over here majority of the time. The molecule itself will be neutrally charged, so this positive and this negative will kind of balance each other out. So when we diagram covalent bonds, we got to show these vacancies for electrons. So when you look at nitrogen, nitrogen has 5 valence electrons, 1, 2, 3, 4, 5. So that means I have 3 spots open for electrons. So I show those as a dash. This means I can have an electron here, here, and here. So instead of showing these dots, you just show it with the dashes. This is telling me that I have 3 spots open for electrons. Here I have oxygen. I have 6 valence electrons. So how many dashes would oxygen have? Oxygen would have 2, so I would draw it like this. Fluorine has 7 valence electrons, so how many dashes would it have? It would have 1, so I would draw it out like so. Carbon has 4 valence electrons, so it would have 4 dashes, and it would look like that. Hydrogen has 1 valence electron, but remember, I don't have 7 openings. This is in that first row. It has 1 ring, and the maximum electrons I can have in that first ring is 2. So hydrogen will have 1 valence electron, so it has an opening just for 1 more. So we show hydrogen with 1 dash. So here's my hydrogen, my first ring, that's my electron. I have room for one more, so that's where that dash comes from. I don't have room for 7. So now what we need to do is we got to draw these out and show our diagram. So you got to draw out your dashes first. So look at oxygen. How many valence electrons does it have on your periodic table? It has 6, so that means I'll have 2 dashes. Hydrogen has 1 valence electron, so that means I will have 1 dash. So my drawing would start out like this. What you need to do is think of this dash and this dash as Velcro strips. These strips have to touch. And when they touch, that means 1 electron is being passed between here and here. So I would go and I would put these two together and that would touch. So 1 electron from hydrogen will come to oxygen, and then oxygen will share 1 electron with hydrogen. So 1 will get passed back and forth. So hydrogen's happy, but oxygen isn't. Oxygen has 6, 7 electrons, but I need 1 more. So I bring in another hydrogen, and this is water. And so now this is showing that I have an electron being passed back and forth here. I have an electron being passed back and forth here. So oxygen has 6 valence electrons, 7, 8. Hydrogen has 1, 2, 1, 2. Okay. When I'm going around checking drawings, you'll see that I'll start counting. Oxygen should have 2 things attached to it. So oxygen has 2 things, 1, 2, it does. Hydrogen should have 1 thing attached to it. So this hydrogen is attached here, this hydrogen is attached there, so everybody's happy. All right, so here I have another one. I have CH4. So I draw out my carbon. I have my 4 dashes. Each hydrogen has 1 line. So remember, these are Velcro strips. I have to touch these strips together, and then that will show my drawing. So let's do the first one. So this hydrogen is going to come here. I'm going to put my line. So now I'm going to attach. The next one will go here. Then the next one I'll put up here, and then this one will go down here. So now carbon should have 4 atoms attached to it, and this carbon does. 1, 2, 3, 4. This hydrogen should have 1 thing attached to it. 1, 1, 1, and 1. What sometimes people will do is they'll do a line here and here. If I had a line here, I have 2 things attached to this hydrogen, and that can't work. I'd have the carbon and this hydrogen, and that's not possible. So just double checking your work will help you guys out with that. Okay, next one is carbon dioxide. So here I have carbon, 4 dashes. Oxygen should have 2 dashes each, and I have 2, so I'll just draw those in. And now I'm going to start attaching lines. What people want to do is they want to attach those 2 together. And if I attach those 2 together, and then oxygen here and oxygen here, I've got 2 lines that haven't been touched. So that can't work. So I have to figure out a way to get all these Velcro strips to touch. So I'm going to take a line and attach this oxygen strip to that one, and then this Velcro strip to that one. So these are going to touch. This oxygen will touch here and here. So this is where most people get. And now we have to start figuring out, well, how do I write this out? Look at this carbon and this oxygen. How many lines did I have to touch between this carbon and this oxygen? 1, 2. So I would draw 2 lines between that carbon and that oxygen. Over here, I have a totally separate oxygen. So I'm going to write out another oxygen. And this carbon and this oxygen, how many lines connect here? I have 1, 2. So when I write it out, I have to show that. This oxygen and this carbon had 2 lines connected. This other oxygen and that carbon had 2 lines connected. So now I double check. Do I have 4 lines touching my carbon? So right here, I've got 1, 2, 3, 4. I'm good. Oxygen should have 2 lines touching it. 1, 2, This one, 1, 2. So I'm good to go. All right, so here I have sulfur, and here I have oxygen. I have 2 of them. So now if I put this line here and connect those two, that works, but then this oxygen's left out, and I can't have that. So I have to connect here, I connect here, and I connect there. So I have to show it like this. So when I write it out, I look, this oxygen's connected to what? I have one line connected to oxygen. I have one line connected to sulfur. So I would write out O with a line, oxygen, come to this one, line, S. And then over here, this oxygen's attached to this oxygen, and then this oxygen is attached to that sulfur. So I would show it like this. This line would connect those 2 oxygens, this connects sulfur, and that connects sulfur. So here I have HOH. So I look at hydrogen has 1 dash. I have 2 H's, so I bring in another one. I Velcro strip, and then I write it out. This oxygen is attached to that hydrogen, so I show a line. This oxygen's attached to that hydrogen, and I show a line. And this is water. So we've already kind of done this. I just changed up how it looked here. All right, that is covalent bonds. I hope that was helpful. Let me know if you guys have any questions.